Assalamu alaikum dear students and welcome to your chemistry fellow. In this video we will talk about chemical reactions of alkenes in detail. So let's start the video. First of all is the combustion of alkenes. Combustion is the burning of alkenes in air. There are two types of combustion, complete combustion and incomplete combustion. Complete combustion takes place in the excess or plenty supply of air, whereas incomplete combustion takes place in the limited supply of air. Now the general equations. For the complete combustion, alkenes burn in excess supply of air to form carbon dioxide and water vapors. Whereas in incomplete combustion, alkenes burn in the limited supply of air to form carbon monoxide and water vapors. Now note down the important point here that in complete combustion, alkenes burn in oxygen to form carbon dioxide. Carbon dioxide is formed here due to the excess supply of oxygen. Whereas in incomplete combustion, alkenes burn in the limited supply of oxygen to form carbon monoxide. Water vapors is the common product in both type of combustion, but for complete combustion, due to excess supply, carbon dioxide is formed, whereas in incomplete combustion, due to limited supply of oxygen, carbon monoxide is formed as one of the product. Now, there are some rules for balancing the combustion equations. For this, you have to balance the number of carbon atoms on both sides of the equation first. Then hydrogen atoms will be balanced, and finally look for the number of oxygen atoms on the product side first. There are two cases. If there are odd number of oxygen atoms are present on the product side, write that odd number with the oxygen molecule on the reactant side and multiply rest of the equation with 2 in order to balance it. In second case, if there are even number of oxygen atoms on the product side, then write half of that even number with the oxygen molecule on the reactant side and the equation will be balanced. Now let's do some example in order to understand this concept. I will write down the equation for the complete combustion of propene. The molecular formula for propene is C3H6. It will burn in excess supply of oxygen to form carbon dioxide with the water vapors. Now, we will balance this equation. As there are 3 carbon atoms on the reactant side, there must be 3 carbon atoms on the product side. So, I will write down 3 as a coefficient with the carbon dioxide. Now, next is the turn of hydrogen atoms. There are 6 hydrogen atoms on the reactant side. There must be 6 hydrogen atoms on the product side. So, I will place 3 as a coefficient here with the water molecule. Now, look for the total number of oxygen atoms on the product side. 3 into 2 makes 6. 6 oxygen atoms will come from the carbon dioxide and 3 oxygen atoms will come from the water molecule. 6 and 3 makes total 9 oxygen atoms on the product side, which is an odd number. So, according to the rule, this odd number will be written as such with the oxygen molecule on the reactant side and rest of the equation will be multiplied by 2. I will rewrite the equation. 2 volume of propene reacts with 9 volume of oxygen makes 6 volume of carbon dioxide with 6 volume of water vapors. So this is the balanced equation for the complete combustion of propene. Now I will write down the equation for the incomplete combustion of propene. C3H6 combines with limited air to form carbon monoxide with the water vapors. Now we will balance it. As there are 3 carbon atoms on the reactant side, there must be 3 carbon atoms on the product side. So I will use a coefficient of 3 with the carbon monoxide. Now there are 6 hydrogen atoms on the reactant side, there must be 6 hydrogen atoms on the product side. So I will place 3 with the water molecule. Now look for the total number of oxygen atoms on the product side. 3 from carbon monoxide and 3 oxygen atoms from water molecules. Total makes 6 oxygen atoms on the product side. As there are 6 oxygen atoms on the product side, which is an even number, so I will simply add half of this even number with the oxygen molecule on the reactant side. It will be 3 oxygen molecule on the reactant side. Now the equation is balanced. Next is difference between the combustion of alkanes and alkenes. Now we will see that as alkanes are hydrocarbons which consist of carbon to carbon single covalent bond, whereas in alkenes carbon to carbon double covalent bonds are present. So alkenes have higher percentage of carbon than that of the corresponding alkane. I have taken 2 molecules here. One is octane which is an alkane. Its molecular formula is C8H18 and its relative molecular mass is 114. Next is octene. It is an alkene with the molecular formula C8H16 and its relative molecular mass is 112. Now I will find the percentage of carbon in both the compounds. Now, as there are 8 carbon atoms in octane and relative atomic mass for carbon is 12, I will multiply it with 12 and divide it with 114 into 100. The answer will be 84.2%. This means that 84.2% carbon is present in octane. Now I will do the working for percentage of carbon in octane. Number of carbon atoms is the same, 8 into 12. I will multiply the number of carbon atoms with the relative atomic mass of carbon, then dividing it with the MR of the compound, multiplying it with the 100. We will get the percentage 85.7. So 85.7% carbon is present in octane. Now both of these molecules consist of 8 carbon atoms in them. But in octane there is 84.2% carbon present in it, whereas in octane there is 85.7% of carbon. So this means that alkenes have higher content of carbon in them. So they burn with more smokier and sooty flame than that of the corresponding alkanes due to the greater percentage of carbon in them. Now, this is a question which may often come in exam. It is, what are the possible products of combustion of hydrocarbons? Now pause the video and think of the different possibilities for the product of combustions of hydrocarbons. It is obvious that hydrocarbons are burned, so the product will be carbon monoxide if it is taking place, combustion is taking place in the limited supply of air. If it is taking place in excess supply of air, it will be carbon dioxide. Water vapors is the common product for both type of combustion. And if the combustion is taking place of higher alkane, means having higher percentage of carbon atoms in them, so unburned hydrocarbon will also present. Unburned hydrocarbon. It is generally written as CXHY. In addition to these 4 products, unburned carbon particles are also present in the soot or the flame. Unburned carbon particles. For unburned carbon particles, the symbol for carbon is used. So there are 5 possible products for the combustion of hydrocarbons: carbon monoxide, carbon dioxide, water vapors, unburned hydrocarbon and carbon particles. So this is all about the combustion of alkenes. Now we will discuss the chemical reactivity of alkenes. As you all know that alkenes are unsaturated hydrocarbons. Unsaturated means that they consist of at least one carbon to carbon double covalent bond. Now due to the presence of this carbon to carbon double bond, alkenes become reactive in nature. Now how the carbon to carbon double covalent bond makes the alkene reactive? What happens is that this double bond of carbon opens up and results in the formation of 2 new single covalent bonds. And as a result of the formation of these 2 new single covalent bonds, atoms from different molecules will be added up. So as addition of atoms takes place in the alkenes when they undergo chemical reactions due to the opening of the double covalent bond between the carbon atoms, alkenes undergo addition reactions. Now, what are addition reaction? First of all, we will discuss its definition. Reaction in which an alkene combines with another substance to form a single new product. As the atoms are only adding up in the alkene, so it will result in the formation of a single product only. No other products are formed in the addition reactions. And it is the identification of the addition reaction that only one product is formed in them. Now, how the addition reactions are represented? The double bond between 2 carbon atoms is open and 2 new single covalent bonds are formed. Now XY is the molecule that is being reacted with the alkene. So what happens is this: the X atom from XY molecule will be added to one carbon atom and the Y atom from the XY molecule will be added to the second carbon atom. As a result, these X and Y molecules are added up in the alkene molecule. As a result, a new product is formed which consists of only single covalent bonds. No double bond is present in it. Now, there are three types of addition reactions which are the part of the O-level syllabus. These are hydrogenation, hydration, and halogenation. The name of the reaction shows that hydrogenation is the addition of hydrogen molecule. Addition of hydrogen molecule. And the hydration shows that water is going to add it. So, hydration is the addition of water in the form of steam. As this reaction is taking place at 300 degrees Celsius, so water is converted into steam. Next is halogenation. Halogenation means addition of halogen molecule. Addition of halogen molecule. Now we will discuss all of these reactions in detail. First of all is the hydrogenation. Hydrogenation is the addition of hydrogen molecule to an alkene to form an alkane. This means that when alkene is reacted with hydrogen molecule, as a result, a saturated molecule alkane is formed. The general equation for the reaction is alkene plus hydrogen makes alkane. Alkenes are unsaturated hydrocarbons and alkanes are saturated hydrocarbons. This means that in hydrogenation reaction, alkenes are converted to alkanes. This means that this is one of the methods for the preparation of alkanes. Now, what are the reaction conditions? Temperature of 200 degrees Celsius is used here with the presence of nickel as a catalyst. And I is the symbol for nickel. Now, let's do some example. First of all, I will explain the hydrogenation with the help of the displayed formula. I am drawing the displayed formula for ethene plus hydrogen molecule. What happens is this double bond is opened up. This one hydrogen atom is added to one of the doubly bonded carbon, and the second hydrogen atom will goes to the second carbon atom. Now what will be the product formed? CH3 and CH3. These are the two new hydrogen atoms that are added up. What happens is this ethene molecule in this reaction, when hydrogen is added, it is converted to ethane. And what are the reaction conditions? This reaction is taking place at 200 degrees Celsius in the presence of nickel as a catalyst. Let's do another example. Propene. This is the displayed formula for propene. Now, I am adding hydrogen in it. What happens is that to the doubly bonded carbon atoms, two new hydrogen atoms will be added up and the double bond is opened up. So, it will be written like this. A chain of 3 carbon atom is formed and rest of the bonds will be made with the hydrogen atoms. These are the 2 hydrogen atoms that are added to the alkene, and as a result an alkane is produced from propene. This is prop. As the double bond is present between carbon 1 and 2, the name of this alkene will be prop 1-ene. So when prop 1-ene undergoes hydrogenation, as a result propane is formed. Now, we will discuss the importance of hydrogenation on industrial scale. It is used for the conversion of vegetable oil to margarine. So, this means that vegetable oils, they are unsaturated in nature. This means that they consist of carbon to carbon double covalent bond in them. They are alkenes. So, when the vegetable oils, they are hydrogenated, hydrogen is added in them, they are converted into saturated hydrocarbons, which are known as alkanes. So, in industries, vegetable oils undergo hydrogenation in the presence of nickel as a catalyst at 200 degrees Celsius temperature. They are converted into saturated hydrocarbon alkanes, which are the hydrogenated one, and they are solid in nature. Now, this is the equation used to represent the hydrogenation of vegetable oil. Vegetable oil plus hydrogen in the presence of nickel as a catalyst at 200 degrees Celsius, margarine is formed. Margarine is saturated, which is known as alkane, whereas vegetable oils, they are polyunsaturated alkenes. What is meant by term polyunsaturated? Poly means many and unsaturated means carbon to carbon double covalent bond. This means that many covalent bonds are present in a long chain molecule. Polyunsaturated means that many double covalent bonds are present in a long chain molecule. So, vegetable oils are polyunsaturated alkenes. When they are hydrogenated, they are converted to margarines, which are saturated hydrocarbons that are known as alkanes. Okay, now we will do a question. And the question is, calculate the number of double bonds in C15H24. So, we have to calculate the number of double bonds in C15H24. For this, I will construct the equation for the hydrogenation reaction first. C15H24 undergoes hydrogenation. It will form an alkane. The general formula for alkane is CnH2n plus 2. So, what will be the value of N here? As 15 carbon atoms are present in alkene, there must be 15 carbon atoms in alkane which is formed. So, I will derive its molecular formula, C15, and hydrogen atoms will be 2 into 15, 30, 30 plus 2 is 32. So, this means that the alkane with 15 carbon atom has the molecular formula of C15H32. Now, I will balance this equation. Carbon atoms are same on both sides of the equation. Now, hydrogen atoms. On product side, there are 32 hydrogen atoms, whereas in alkene, there are only 24 hydrogen atoms. In order to balance the number of hydrogen atoms, I will put 4 as a coefficient with the hydrogen molecule on the reactant side. As one hydrogen molecule is added for each double covalent bond, this means that 4 molecules are added for the 4 double covalent bonds. So, this means that in the given alkene C15H24, 4 double covalent bonds are present. I hope you get this concept. Next is the types of margarine obtained during the hydrogenation reaction. There are 2 types of margarine, soft margarine and the hard margarine. If alkene undergo partial hydrogenation, then what happens? Soft margarine will be formed. If the partial hydrogenation of vegetable oil is done, then soft margarine is obtained. If complete hydrogenation of vegetable oil is done, then the hard margarine will be obtained. What is meant by term partial hydrogenation? Partial hydrogenation means that all carbon to carbon double bonds are not hydrogenated. All carbon to carbon double bonds are not hydrogenated. Whereas complete hydrogenation means that all double bonds are hydrogenated. So, complete hydrogenation result in the formation of hard margarine and partial hydrogenation result in the formation of soft margarine. Soft margarine will be oily in nature due to the partial hydrogenation. As vegetable oils, they are oily in nature, they are polyunsaturated, so they are oily in appearance. So incomplete hydrogenation result in the soft margarine which has which is oily in texture. So this is all about the hydrogenation of alkenes. Now, next is the hydration of alkenes. Hydration, as the name of the reaction shows, that water will be added. So, hydration is the addition of water molecule in the form of steam to an alkene to form an alcohol. What happens in hydration reaction? Alkenes reacts with steam to form an alcohol. How is this happen? Alkene consists of carbon to carbon double covalent bond. When steam is added, what happens is this: double bond opens up and as a result 2 new single covalent bond will be formed. and as a result of this opening of covalent bond, hydrogen atom from steam will be added to one of the doubly bonded carbon atom, and hydroxyl group is added to the second doubly bonded carbon atom. So hydrogen atom will be added to one carbon atom and hydroxyl will be added to the second carbon atom. As a result, alcohol is formed. Now what are the reaction conditions for the hydration? Temperature is 300 degrees Celsius. This reaction takes place under pressure of 60 atmospheric pressure in the presence of phosphoric acid as a catalyst. Now let's do some example. Let's take ethene C2H4 plus steam. Steam is used as a reagent here. So I will write down the reaction conditions on the arrow. 60 atmospheric, 300 degrees Celsius temperature, and phosphoric acid is the catalyst, and as a result alcohol is formed. In order to write down the formula for an alcohol, I will write down its general formula first. CnH2n plus 1 OH. Now as two carbon atoms are present in alkene, there must be two carbon atoms in alcohol, so N will be 2 here. So H, 2 into 2 makes 4, 4 plus 1 is 5, C2H5OH will be the formula for ethanol. So from ethene molecule, ethanol is formed. It is always recommended to write down the chemical formula in the equation. This is the chemical formula for ethanol. What is the chemical formula? It represents the type of elements present in the compound as well as it represents the functional group present in it. So it will be easier to identify what type of compound is formed as the product during the reaction. Let's do some more example. For example, I am taking prop 1ene. A chain of 3 carbon atom will be made with a double bond between carbon 1 and carbon 2. So I will draw the remaining bonds with the hydrogen atoms. There must be 6 hydrogen atoms in prop 1ene, as its molecular formula is C3H6 plus steam. What happens is that the double bond is opened up, 2 new single bonds are created, and rest of the molecule will remain the same. I will show the new 2 bonds with the blue pen. Hydrogen atom from steam will be added to one carbon atom and hydroxide will be added to the other carbon atom. As a result, from prop 1ene, as OH group is present on the first carbon atom, so propane 1-ol is formed. Also, there is an option that the OH may attach with the second carbon atom. So what will be the product formed then? Its structure will be like this. OH with the second carbon and rest of the carbons are bonded with the hydrogen atoms. So as the functional group is present at carbon number 2, so the name of this alcohol will be propane 2-ol. So you have a choice to write down any one of the product as a result of the hydration of prop 1ene. Now I will explain you a tricky concept here, and the questions may often come from this concept, so it is very important to understand this concept. So this concept is about symmetrical and unsymmetrical alkenes. I have taken 2 alkene molecules here. The first one is but 1ene and the second one is but 2ene. So why is this but 1ene? As 4 carbon atoms are present in the chain, so prefix but will be used. Double bond is present, so name will be end with ene, and 1 represents the position of functional group in the compound. And do remember that while writing the name of an organic compound, you have to mention the position of the functional group in it. So always start numbering from the side which is nearest to the functional group. Okay, so the name of this compound is but 1ene. In this case, this is but 2ene. Now 4 carbon atoms are present, so I have used the prefix but here. As double bond is present in the chain, so name ends with ene, and 2 represents the position of the double covalent bond in the compound. I may start numbering from the left side or from the right side, because from both sides the double bond comes on the second carbon atom. 1, 2, 3 and 4. So the name of this alkene is butene. Now in butene you see here that on both sides of the double bond there are same groups of atoms on both sides. On both sides of the double bond in butene, same group of atoms are present on both sides of the double bond. So these type of alkenes are known as symmetrical alkenes. What are symmetrical alkenes? In which same group of atoms are present on both sides of the double bond. Whereas in but1ene, on both sides of the double bond, different groups of atoms are present. On the left side there are 3 carbon atoms, whereas on the right side there is only 1 carbon atom. So different groups of atoms are present on both sides of the double bond in but1ene molecule. So but1ene is an unsymmetrical alkene. This is an example of unsymmetrical alkene. So what happens is that when symmetrical alkenes undergo hydration reactions, they react with steam, only one type of alcohol is formed. Only one alcohol is formed. How? What happens is that this double bond is open up, okay, and we have an option that the hydroxyl group of water, it may be added to second carbon atom or it may be added to third carbon atom. If it is added to the second carbon atom, what will happen? The name of alcohol will be 1, 2, 3 and 4. 4 carbon alcohol is formed, so it will be butane and the suffix will be ol. Now, what is the position of the functional group? It is present at carbon number 2. So, the name of the alcohol will be butane 2ol. If it is added, OH group is added to the third carbon atom, what happens is this: I will name the alcohol and start numbering from the side which is nearest to the functional group. So I will start numbering from the left side, first, second, third and fourth. 4 carbon atoms are present, butane, and suffix will be ol. And what is the position of the functional group? It is again present at second carbon atom. So both the products are butane 2ol. This means that when symmetrical alkenes undergo hydration reactions, only one alcohol is formed as the product. Whereas in case of unsymmetrical alkenes, as there are different groups of atoms that are present on both sides of the double bond, so 2 different type of alcohols will be obtained. If OH group is added to carbon number 1, then the alcohol will be like this. The OH group will be present at carbon number 1. What will be its name? I will start numbering from the side which is nearest to the OH group. 1, 2, 3 and 4. The name of alcohol will be butane 1ol. But if OH group is added to the second carbon atom, what will be the name? 1, 2, 3 and 4. Now the OH group is present on the second carbon atom, so the name of alcohol will be butane 2ol. So butane 1ol and butane 2ol, both are alcohols, both consist of same number of carbon atoms, but due to they are different molecules due to the position of the functional group present in them. So as a result of the reaction of unsymmetrical alkenes with the steam, when they undergo hydration reaction, 2 types of alcohols are obtained, or you can say a mixture of products are formed. Whereas in case of symmetrical alkenes, only one type of product is obtained. I hope you have got this concept. Okay, now some of the key points regarding the hydration of alkenes. What are these key points? All types of alcohols can be prepared through this reaction except methanol. Methanol cannot be prepared from the hydration of alkenes. Why? Because methanol consists of only 1 carbon atom, whereas 1 carbon atom alkene does not exist in nature. Why? Because for alkenes at least minimum 2 carbon atoms are required for the formation of double covalent bond. Next is, this method is used for the preparation of alcohols on industrial scale. Why? Because this is extremely fast and efficient method. So in less time we will get the large yield of alcohol. So this method is used on industrial scale for the preparation. So as only one product means that only alcohols are formed during the reaction. So through this reaction pure alcohols are prepared. This is all about the hydration reaction of alkenes. Now is the halogenation of alkenes. It is the addition of halogen molecule like chlorine or bromine in the presence of carbon tetrachloride as a solvent at room temperature and pressure to form haloalkene. The general reaction is alkene plus halogen, they react at room temperature and pressure in the presence of carbon tetrachloride to form haloalkane. What actually happens in the reaction is the double bond between the carbon atom, it opens up, and as a result two new bonds are formed. I have shown these two new bonds with the orange color, and what happens is that the halogen atoms in the halogen molecule, one halogen atom will add up to the one of the doubly bonded carbon atom, and the second halogen atom will add up to the second doubly bonded carbon atom. So as a result, a new haloalkane molecule is formed. Now we will do the bromination of alkenes. In bromination, addition of bromine molecule, or you can say that addition of aqueous bromine solution is added to an alkene. What happens in the reaction is, if an alkene is passed or added to the red-brown solution of bromine, it immediately decolorizes. For example, as ethene is a gas, so we will use the term passed. So if ethene gas is passed through the aqueous solution of bromine, it will immediately decolorizes it, and as a result dibromoethane is formed. This is the dibromoethane molecule. So as in the diagram, it shows that aqueous solution of bromine is of red brown or orange in color. When alkene is added to it, it will immediately decolorizes due to the formation of haloalkane. Now what is the importance of bromination of alkenes? It is used as an identification test for unsaturation in a compound. This reaction is used as a test to check whether the compound consists of double bond or not. If a compound is consisted of double bonds, then it will immediately decolorizes the aqueous solution of bromine. If double bonds are not present, the solution remains unchanged. It is used to distinguish between alkanes and alkenes. For example, here is a test to distinguish between hexane and hexene using bromine water. The aqueous solution of bromine is also known as bromine water. On the left hand side, both of these test tubes consist of bromine water. Hexane is added to the left test tube and hex 1ene is added to the right hand side test tube. After the reaction, the solution in the left hand side test tube, it will remains unchanged. As hexane is a saturated compound, it consists of only carbon to carbon single bond, so it does not decolorizes the aqueous solution of bromine. The solution remains unchanged. Whereas in the test tube in which hex 1ene is added, it immediately get decolorizes. The solution in the test tube, it becomes decolorized. The orange color of bromine is discharged. So this means that this confirms the presence of carbon to carbon double bond in hexene. So this is all about the halogenation reactions. Now we will summarize all the addition reactions of alkenes. First is the hydrogenation. Hydrogenation is the addition of hydrogen molecule to an alkene in the presence of nickel as a catalyst at 200 degrees Celsius, as a result of which alkanes are formed. And this reaction is used industrially for the preparation of margarine from the vegetable oil. Next is the hydration reaction, in which steam is added to an alkene at 300 degrees Celsius under 60 atmospheric pressure in the presence of phosphoric acid as a catalyst, and as a result alcohols are produced. This is one of the fast and efficient method to produce alcohols and is widely used in industries to prepare alcohols, as pure alcohols are formed during the reaction. Next is the halogenation reaction. Halogenation is the addition of halogen molecule to an alkene to form an haloalkane. This reaction takes place at room temperature and pressure in the presence of carbon tetrachloride as a solvent. And bromination is the halogenation reaction, in which alkene molecules, they are reacted with aqueous bromine to form bromoalkanes, and this reaction is used to distinguish between alkanes and alkenes. Basically, this reaction is used to test the unsaturation in a compound. So this is all about the alkenes, their reactions and their properties. So I hope you have got all the points that are explained in this video, and if you like my videos, do share and subscribe to my channel. Thank you so much. Allah Hafiz.